But why do I not see anything? Let me see if we're live actually on YouTube. I'm curious. Oh, there we go. Good. Oh, we're up. We're up. Oh, there we go. Nice. Is River in this channel? I don't think River is in this channel though. There we go. Cool. Nice. Okay. That's back. Mm-hmm. I'm at least not dropping frames anymore. Happy about that. I would like my chat to work correctly. Oh, there you are, River. Okay. I think we got it back. Okay, there we go. Okay. River, can you see all this at least well? Is this all good now? I think it should be better, yeah? Okay. So yeah, cells that are dividing here, I think are just cells that don't look like the normal cells here. So I think you have to just like count which ones those are. Then once you got that, select the bar charts, show numerical values, how many cells are in the interphase stage. Is there a way you can show me what's happening here? Like, can you show me a screenshot of like what's happening here to do this? It says, based on these two observations, would you say a cell spends most of its life cycle in interphase or in mitosis cytokinesis? I think cells spend most of their life in the interphase instead of mitosis. Mitosis is when they're splitting and producing into new cells. Okay. The interphase, I think, is where they spend most of their life. Yeah, what's up, Wonder? Wonder, what's up, dude? Wonder, we did your question earlier. It was, which one was it? It was, I did this one for you. A biology question. I know, right? Yeah, we did this one, Wonder, and then this one, which my viewers also agreed is just like poorly written.
You done messed up, AA Ron!
Okay, awesome, cool. He's watching it, great, yeah. Sorry, we were down for the last 10 minutes. I had to reset my internet router because like we were just dropping frames like crazy. I don't understand what was happening. We just got rain in LA, and we almost never get rain, so maybe the rain was like messing with things. I don't know, it happens sometimes. Well, we're gonna get through an advertisement here. I should really they should give me YouTube whatever premium for free if I'm a partner, right? Shouldn't I get YouTube premium for free? Los Angeles? Yes, I do live in LA. Yeah, that's me. Is LA tough? It's expensive. It's definitely expensive. I like it though. Oh wow, this is like an 8-minute video. I don't know if you need to watch an 8-minute video. But I like the animation. This is the cutest like biology thing I've ever seen, dude. Yeah, okay. Anyways. So yeah, in general, River, cells spend most of their life in interphase. Use Brave. I just switched to Brave because of the ads. Yeah, content creators should get it for free. Yeah, right? Yeah, what? Why am I getting served ads? I'm providing money for YouTube. Excuse me? It's fucking rude.
Surprise, motherfucker.
No. Okay. Cool. Yes? Good? I think we did this question. Nice. Sume says it's been 5 minutes. I'm already loving the stream. Nice. Yeah, we do a lot of fun stuff here. We just had a little technical thing. I had to reset the internet. Okay. So that means we've done clickbait, Rivers, but now clickbait has another question. So let's see what clickbait submitted. So again, if you're just watching us from YouTube, if you go to that website, actualofficehours.com, you can type your username in and drop in a screenshot of a sample homework question if you want to go through one. And then you can click here on the live queue to see who submitted questions. Clickbait's submitted some. It's a 3-star question. Oh, man. Okay, fine. Wait, is this like 4 springs attached to each other? Consider the mass attached to 4 identical springs. Each spring has a force constant K. I'll be streaming for the next hour. River, if you want to ask another question, just submit it. I'll go through it. Because honestly, I might punt on this one again. Clickbait just keeps giving me hard questions that I can't solve. Oh, man. When the masses displace a distance xy, show that its potential energy has the form 1/2 k prime r squared, appropriate to an isotropic harmonic oscillator. Cool. What is the problem? What is k prime? Oh, you're going to donate to me when you get some money from your parents? Thanks, dude. You don't have to. Like, this is free. We're a nonprofit, but I appreciate the donations. We use the money to buy gift cards to reward students for doing well in school. So we appreciate donations. They're awesome. But yeah, all the teaching here is free. But yeah, if you got cash and you want to send it our way, we'll definitely use it. Because we buy other gifts for other people. Yeah. Yeah, we gave out a Nintendo Switch 2 over the summer. We had a little summer camp. It was pretty fun. We reward people for doing good. We do. Yeah. So if you don't know about us on Discord, if you join our community, we have a bunch of different challenges you can do to get points. So for instance, I have like a touch grass challenge where if students show me that they got at least 7,000 steps a day for 4 days, you get points. If you show me you have good grades, so this is like the good grades channel. So if people show me like, hey, look, I'm doing really well in my classes, you get points. You can play a musical instrument. Some people show me that they play musical instruments. I think that's really cool. I like music. I play the cello. So if you show me you play a musical instrument, you also get points. And then, of course, the easiest way to get points is to join the stream and ask questions. You get a point every time you ask a question. At least once during a day. Yeah. Yes. Yes, that's what we do. We're cool. We're a nonprofit. We like to encourage people to... I like to say that doing well in math and science is kind of the same as like grinding at a video game. Ask a question, get a point. Yes, nice. That's a good ticker. I like that one actually. Here, let me change that ticker. That's a good one. Where's my ticker bar though? I had to fix my ticker bar because it was like doing weird things. I'll find it later. It's somewhere. You're a good person. I appreciate that. Just trying to make the world a better place. Not many people like you nowadays. I think they do exist. I just think the media amplifies all the bad people, unfortunately. Like, all you hear about are bad people because bad people do extreme shit and extreme shit gets clicks. There are plenty of good people out there. They just don't generate as many clicks. Like, rage bait is so much more popular. Accumulate points, get money. Yeah, exactly. Yeah. Okay. And the length of each spring when the mass is at equal important point is A. Not necessarily the same as L naught. Dude, clickbait. What even is this, dude? What fucking physics are you in that you're being asked these questions? How do you even earn a living being a nonprofit content creator? I teach physics at UCLA, which I'm not teaching this quarter, but I usually do. And then I also tutor a lot of students for a lot of money. I charge a lot of money to some students, but those students have very wealthy parents. So they pay me to teach their students one-on-one, and then I take that money and I teach you guys for free. It's kind of like a little like Robin Hood situation. Yeah. I mean, it's a win-win. The really rich parents get really awesome one-on-one time with me, and then those that don't have rich parents can still get help. I feel like math and history is easy, and ELA and science is hard. Yeah. This is Classical Mechanics 1 at ASU. Y'all been in the sun too long, dude. This is not classical mechanics. I mean, this is like upper division mechanics, maybe. Yeah, you get the same thing basically for free, yeah. Well, yeah, a little bit like the same thing, but I can't answer like everyone's questions. Like, you have to wait a little bit sometimes because there's like a queue. Although, yeah, this is the only question in the queue. So if anybody else has a question, please submit one. Gold is one of the most successful cases I know. Oh, I appreciate that. Thank you. Okay. This is a 3-star question, which I know is already a nightmare in like college level. So I'm gonna shamelessly throw this into ChatGPT because at least we're gonna stress test it. Solve this. Show me, and then I'll try to explain it to you guys. Is that cool? ChatGPT is great for learning. I have no shame in using ChatGPT to learn. If you're using it to just copy and like do your homework, that's bad. No. You're not gonna learn anything. Oh, you're happy you found me while scrolling? Great. What's up, Eon Gamer? Do an AP Physics C problem involving torque? Ooh, okay. We could do one of those. Let me see what this is. Well, we'll see what ChatGPT comes up for like a solution. But a torque question. You want like a statics question, maybe? So a good way to study for AP Physics C is to just look at what the practice tests are. So I think like the FRQ, practice FRQs. Or they actually have the public exam. Oh wow, they have this. Oh, very cool. So what do you want? You want like a multiple choice question? Multiple choice or FRQ? I found him using my very, very smart friend. He's like the best at math. That's dope. Okay. You want a torque question. He said he wants a torque question. Trying to find some torque. Oh, it popped out as a short. Then I got interested in the math. I found it awesome. Now I'm sticking around. W, dude. Love that. Love that that's how your journey is to find us. Bless the YouTube algorithm. Force on a comment. Dude, is there no torque in AP Physics C? I'm looking for some. Yeah, there was none here. What the fuck? I've been since 2021, so I've been streaming for about 4.5 years. Almost 5. We're coming up on 5. Bro, there's no torque on this multiple choice question. Physics 310. I'm supposed to be sleeping, but your content is addicting? Oh, that's dope. Okay. Oh, this is cool. All right, whatever. Let me just do this question. This is kind of cool. I like this one. Yeah. This is what chat came up with, by the way. I'll try to understand this at some point. Linear quadratic. Oh dear, like no. Not doing that today. Okay, it says a ball is stuck at a time t equals 0, is struck at a time t equals 0, and follows the parabolic path shown in the diagram above. The following graphs show the quantities possibly associated with the motion as a function of time t. Assume that air resistance is negligible and that positive directions are up and directions to the right are also positive. Okay, cool. And so then the questions are... which of the following graphs represents the horizontal component of the velocity of the ball? Okay, so when the thing is struck, okay, and it follows like some path like this, that tells me right away that there must be some initial velocity in this direction, right? And then that initial velocity, if it's at an angle, right, must have components. So components there, you can have like v naught x, which would be this way. Right here, let's like break it up. There you go. This would be like v naught x. And this right here would be equal to v naught y. Okay. And then as this ball moves through the air, right? 3 a.m. in the UK. Wow. Staying up late. Things are going to change. So as it goes up, right, it starts to like slow down in the y direction. And the reason for that is that there is a force of gravity that's pushing it down. So gravity is a force, and that causes an acceleration downwards equal to negative g. Okay? And so what that's going to cause for the velocity in the y direction, the velocity in the y direction here is going to be very big. And then as it gets up towards the top, that velocity is going to decrease in the y direction to eventually be 0. Okay? And that means it's no longer to be going up, because then the velocity is going to start becoming negative in the y direction. And that's why it starts falling to the ground faster and faster and faster. Okay? But that's the y direction. In the x direction, okay, whenever you want to think about if velocity is changing, you have to think about what forces are acting on something. Because what we learned in physics is that acceleration is equal to change in velocity over change in time. And that acceleration, A, can also be related by F is equal to ma. So that's also equal to the force divided by the mass, okay? So if you ever want there to be changing velocity in a certain amount of time, you need there to be some force, right? If this is 0, if there's 0 force acting, then there is also 0 acceleration. And that means there's 0 change in velocity. In the x direction, there isn't any force. This thing is just like chilling up in the air. So while there is force in the y direction from gravity that's pushing it down, there isn't any forces in the x direction. They also say ignore wind resistance. I know air resistance, whatever, is technically something. But that means the velocity in the x direction is constant. So when they say which graph represents the horizontal component of the velocity of the ball, that's going to be choice E here. Because that's the only one where velocity is a constant value for all different times t. Cool. Okay, vertical component of the velocity ball, that's a great one. So this one was answer choice E. If you look at the vertical component of the velocity, again, remember, at the beginning, you have lots of up velocity. And then as you start getting higher and higher, eventually the up velocity goes to 0. And then it starts to switch directions. And that's what causes it to fall to the ground faster and faster. So looking at that, I need something that has initially a positive y velocity, goes to 0, and then goes to negative. That's this graph, D. You have a positive one, eventually going to 0, eventually going to negative. Oh, what's your Discord? Yeah, you guys can hate each other in Discord. I don't care. You guys can take up the chat. I don't really care. Your mom should be so proud. Yeah. Okay. A bedtime at 14? It's okay. I had a curfew still, like, up until... Even in college, my parents still tried to enforce a curfew. But then they're like, oh, it's our house, it's our rules or something. I'm like, okay, fine. Yeah, I don't care. If anything, it boosts my engagement because they see more people in the chat. I'll take the metrics. Okay, cool. So that's answer choice E. Answer choice D Nice. Okay, let's see. Paulin has given me an interesting question. Wow. Oh, these are always fun. Is this a fucking rectangle of resistors? Determine R1 for the network in the figure. Okay. Frick this, I'm gonna stay up. Yeah. My parents, I just lock my door. Dude, my parents would like beat my ass, dude, if I locked my door. What? That's hilarious. Y'all just lock your door, like, fuck it. Oh, man. My parents are always walking in and acting like I'm a criminal. Maybe you are a criminal. I don't know. Like, what are you kids up to? I was pretty devious when I was in high school. I'll give you that. Okay. I think the way to do this, I need to like get this out in like a 2D form. Or I can kind of think about like nodes, right? Is she throwing the chanclas at you though, River? Dude, that's when mom's really mad at you. She throws the sandals. Yeah. RT equals 10. Wait, sorry, what does RT mean? Is that the resistance across here and here? Isn't that also just what R1 is? Or is this a... okay, wait, I see this. Is this R Thenovin? I can see in your eyes that you're into these types of questions. This is pain. The undead tired eyes. Yes. Look into my eyes. I'm having so much fun with this one. Oh, R total. Oh, I'm dumb. Yeah. Wait, R total between what? Oh, between here and here. Yes. Okay, thank you. I thought we were talking about Thenovin for a second. Okay. 3D shapes are really difficult to work with. I want to try to, I think, condense this into 2D. Yeah? Like, so here's a cool thing. Anytime you see, like, an open wire and, like, nothing's happening, you can always kind of think about just taking these two bits and, like, connecting them over here, like, as a single thing. Okay? These circuits have kind of a visual nature to it. You have to be pretty good at, like, spatial visualizations. And then, okay, so let me try to draw things. Okay, we're gonna say from here to here. Okay, I know this is at least a resistor, right? Man, I don't know how I managed to squeeze a D+ in circuits first try. Yeah, it's tricky sometimes. Okay, so then I like to always think about, like, branches, like what's happening, right? So I know from the top of this over to here, that's at least doing 24 ohms, okay? So let's like, I like to like draw these things because I think this will help us. Like, let's color code this. Let's make this like a fucking like beautiful picture. Okay. And then this is interesting. I have wire that goes from here to here to here and then comes back. Interesting. Doesn't that kind of just like negate? Doesn't that negate the 24 ohm resistor? I feel like I don't even care about the 24 ohm resistor then. Right? Are you guys trying to determine like who's who? Like, look at this. Do you see how this comes from here? It comes from here. It comes from here. Now, oh man. Yeah, that's weird. Okay. So wait. So there's also this happening. I don't even know. I feel like that just, like, if you have a straight wire, that just fucks everything up. Okay. Path of least resistance. Is that what we do? Okay. All right, cool. That goes to that. Couldn't you calculate all the parallel R and then add them together in series? Yeah, I want to try to, like, take this 3D shape and put it into 2D. I feel like that helps me out. I gotta delete my account now. All right. And then let's see this. This is a 24 ohm resistor, right? And this comes down from this juncture here. Right? Here, let's keep the resistor colors so I can at least see them. "2D is cursed." You don't like the 2D? I feel like this is what I would do. Guys, get out of chat. Why? Why, River? There are people finding the info. I don't know whose info. Like, your first name is not enough information to do much with. He knows my name. Bro, you can look up my home address on the fucking government website. Oh yeah, the 3D looks devilish. Yeah, I don't like this. Okay. Because then here's the cool thing. Do you see how this green here then connects to here? That tells me that connects to the other side of R1, right? So that comes here. Okay. And then what I see in the middle of this orange, right? As we're connecting from in here, I have two 24 ohm and a 120 ohm resistor. So let's do that. So here we go. This is the 24, right? I haven't connected to anything yet. 24. And then I also have... Oh, I'm running out of colors! Okay, no, I still have this one. Okay. I have the 120. Okay. This is 120. Now, those go in parallel with another 24. Okay, cool. Once I have it in 2D, I feel like I can see what this fucking thing is real quick. Okay, we're close. And now I just need to see what happens. Okay, so at the juncture between the red and the purple, that needs to connect back to the green. Okay? So, that's going to be this. And then at the juncture between the pink and the purple, or pink and the whatever, fuchsia, periwinkle, what the fuck color you call this, this needs to connect to the other side of the blue. Okay, there we go. Right? Magenta. I agree. Magenta's better. Well, like fuchsia? Maybe fuchsia? Okay. Okay, very cool. Alright, so here's our circuit. And then we know RT is equal to 10. And I think they're saying the resistance across the entire thing. Okay. Okay, let's try to, like, piece this together. Okay, here's the cool thing. Fantastic fuchsia. Yeah, it is fantastic fuchsia. So whenever things are on a wire and nothing's in between, I can always, like, loop them together, right? So I can connect this part up to here, and I can connect this part up to here. That's kind of like how I think about this. Let's think about that. Connecting to that. Right? I think so. Oh, wait a minute, wait. But they're all connected to each other. Uh-huh, uh-huh. Oh, this is even weirder. Wait, wait, whoa, whoa, whoa. Wait, these are connected to each other. Oh. So this can go on either side. I think the 24 ohm resistor here doesn't do anything. Because if current is trying to get from here to here, think about the paths it can take, right? It can either go straight across. Cool. So I know R1's at least one path. And then current has another path, right? It could... Sorry, excuse me. So it tells me that the total resistance is 10, Danielle. And it wants me to find R1. And I believe it's between these 2 points. I think that's the resistance we're trying to figure out. So I'm trying to think, if I ran a current through here, where would current like to run through, right? So current could run through R1. So that's at least one, like, branch. And then another parallel branch it could kind of run through, right? So it could run through here. Just multimeter it. We could actually, you know, here's the funny thing. I could throw this bitch onto, what's it called? You know, like the circuit builder thing? Do you guys know what I'm talking about? Like the FET circuit builder? Pretty sure I could. What's that? OrCAD, yeah. It's something like this. Just laid out as a net? Okay. Well, I'm trying to see, like, what resistors matter, right? If current goes through here, cool. Current could also go across the 24, but why would I go across the 24 when I can jump right across it here, right? So I feel like this 24 ohm resistor is negated. Like, I don't care about this resistor, right? Because any path over here would be infinitely easier to just do this. Yeah? Then in that case, right? Now I have this position, and this position can all melt together onto here. Hostel says that's not true. Explain to me why that's not true. There's a load with those middle resistors. Yeah, but they're not on this line. So look, this is the diagram we have, right? And I color-coded it for you, hostiles. So, like, this is blue, this is blue. Do you see how I could just bypass this purple one by just going all the way around it? Here, and this is the original question, right? Like, I don't see the point of going across the 24, because you can just... Yeah, okay, cool, you get it. Nice. No, I appreciate it. Thanks for, like, questioning it. Like, I always need to be questioned. And it helps reinforce my understanding. Okay, so let's just agree that that 24 ohm resistor is cheeks. I don't fucking care about it. But it still goes in it. Why? Why would it, goat? It doesn't need to. Current only goes where it needs to. If I have a circuit, for instance, okay, I'm going to show like a simple example. Nice. If I have a circuit that looks like this. And you ask me to figure out the amount of resistance in this circuit, the amount of resistance is 0. Because, and again, we're assuming that the wires don't have inherent resistance. This is an ideal case. No, but watch here. R equals 0. It has a path connected to the circuit. Yeah, but it's a short. This is we're going to assume there's no resistance in the wire. Say this is like R equals 100, right? If you wanted to find the total resistance in this, right? That would be 1 over 100 plus 1 over 0 to the minus 1, right? These are two things in parallel. This is fucking huge. So you get infinity to the minus 1, which is equal to 1 over infinity, which equals 0. Effectively. Right? I don't think shorts contribute to resistance. Okay. So, for now, I'm just gonna get rid of it. Screw it. All right. And then so let's redraw what we got for our circuit, right? So now this is gone. And let's consider what's happening here. This is really cool. So I see that all of these connect to here. Get wrecked, 24 ohm. Would the middle resistors constitute to a pull down? I think so. My PhD is in physics, so I have a basic knowledge of circuits. Like, I know KCL, KVL. I can do a little bit of Thevenin stuff. And I understand, like, you know, basic Kirchhoff shit. Bye, River. Good to see you. So this is the same thing as connected Doctor Actual Education. We're trying to figure out total resistance. So this is going to have the 24 ohm. Or here, actually, it has to do something like this. One sec. Okay, we have the 24 ohm coming. Oh, but then there's other things happening. Damn it. His name is Dr. Gold. It is Dr. Gold. That is my name. Don't worry now. Okay, let's just have this happen just for now. And then I'll deal with the other connections as we get there, okay? So I know this is 24 ohms, right? Because if all of these points were to merge onto this, this would be at the end of this, and then I need this to come down to the end of this. I'll deal with the other stuff in a second here. Okay, on that branch, I also have a 24 and a 120, right? Okay, so this is my 24. This is my 120. And then here's the interesting thing. The 24 in between them then also connects. Oh, it's like a wheat stone. Oh, watch this. It's actually really cool. Okay, watch this. And then this the 24 is in between them, right? And then, but look what happens, right? At these junctures, these all connect to the green. So I can also just put connections like this. Cool. Oh, sorry, I had the wrong screen on. My circuits make terms are so cooked. Yeah, I hope not. It's not too bad. Okay. You kind of understand it? Yeah, exactly. One sec. Oh, I should have had my. One sec. I need my. This is physics, yeah. The pink 24 is also shorted. Why do we think the pink 24 is shorted? V equals IR is all I know. Current can go around it. No. Oh, I think you're right. I think you're right, Anthony. Yes, right? Because again, why would I go down the 24 when I can just go home? And same with the 120. Why would I go across the 24 when I just go home? I think I have to agree with Anthony here. I think the 24 is also shorted. Or it's like it's useless. It's like the current always has a choice, right? So it's just 4 resistors in parallel. I think so. I think that's literally all it is. Advanced function sounds more complicated to me. Why can't it just go through the shortest path? So, key thing here, because let me show why this there's a fallacy to this. If one of the resistances is not 0, okay? Let me just show it to you real quick. Okay. For those that don't know circuits, because I have some high schoolers in my stream right now who have never seen this, or they've seen a little bit of it. Okay. Let's say you have 2 resistors, okay? And let's say this is like 10 ohms, and let's say this is 20 ohms, okay? And you have current, right, which is flowing, okay? The current's going to get to this juncture, and it's trying to get to here. You're only a freshman. That's totally cool. So, going through the 10 is easier than going through the 20, but not all the current wants to go through the 10, because it actually would make life easier if it distributed some of the stuff to go through the 20. Okay? I think the way to think of this, let's say you're like trying to like pick a line to go eat things for lunch, right? And let's say that this line is running twice as fast as this line. Do you want everybody to go through the fast line? Because then the fast line has a massive amount of fucking people on it. Versus you want to have more people go on the fast line, but you still want to send some people to the slower line, because they can still serve people in the line while the fast line's still, like, processing, right? What's bro saying? Yeah, I'm trying to explain how, like, parallel circuits work. The math for this is that, like, R total is equal to 1 over 10 plus 1 over 20 to the minus 1. Okay. That's another way to do it, just. Yeah. Exactly. And so Anthony brings up a very good point. If one of the lines is infinitely fast, then no one goes in the slow line, right? If one of the lunch lines is just saying, like, fuck it, like, all the lunch is free and they don't charge anybody, everybody should go through that line. Because nobody waits, right? Yeah. Mary says he thinks it's easier to talk about equipotentials. I don't think to a high school student that hasn't seen voltage yet. Yeah. Anyways, this is the equation. It's 1 over R1 plus 1 over R2 to the minus 1. The other cute way they write this, right, is this R1 R2 over R1 plus R2. I think that's the other fun way to write it, yeah? What's up, high potential? When in doubt, Kirchhoff's law. Yeah, dude. Yeah, shout out. But speaking of potential, you are the high potential, dude. Chat. Thanks, dude. Yeah, okay. The part Anthony brought up is, like, if this is a short, so if this is just a plain wire, okay? So let's say this now has a resistance of 0. Now when one of these resistors is 0, okay, you end up getting 0 over R1 plus 0, and now the effective resistance is 0. And so that's why this resistor doesn't have an effect, because now there's an infinitely easier way to go down. Yeah. If you have any questions, please, there's a queue down there. Do you see that? www.actualofficehours.com. If you have other screenshots of questions you want me to go through, where is it? Right here. This is the website. Go to the website, type in your username, drop me a screenshot of what question you want to go over, and I'll do it live here on the stream. And then if you ever want to see what's being worked on, just click on the queue here. We only have like 2 questions so far. It's been pretty chill today, so I'm happy to do more questions with you guys. So if you got something on electrical potential, yeah, take a screenshot and just send it. Okay, so anyways, I think I agree with Anthony here, and I'm going to get rid of this one. Because why would the 24 ohm try to make life more difficult? Why would the current coming out of here make life more difficult and go backwards and go through something else that sucks? And why would the 120 do it? No, they can go straight down to the leg and get back to the thing. Oh, nice, cool. Yeah, well, let's see if we get the right answer. I think this thing's gone. Okay, cool. All right, so now I just have four resistors in parallel, and so R total is going to equal 1 over R1 plus 1 over 24 plus 1 over 120 plus 1 over 24, right? To the minus 1. And they told us in the question that R total, sorry, is equal to 10. Me and the homies hate 24 ohms. Yeah, yo, cap the 24 ohms, dude. Okay, whatever. We can get rid of this. So 10 is equal to Let's get common denominators. I think 120 is the common denominator, right? So this is 120 over 120 R. Wait, no, I just leave this. Sorry. Oh, it has to be 120 R1. Okay, 120 over 120 R1 plus that's 5 over 120 plus 1 over 120 plus 5 over 120, and then multiply these all by an R1, 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 R1. Oh, Jason says to do it by like, by loops. Take the KVL, the bottom loop, voltage drop across the 0 must be 24. Yeah. I agree with that. Yeah. Oh, he's so great here. Yeah. Right? Okay. If you were to look at Kirchhoff's voltage law here, KVL, there's no voltage source here, right? So the sum of the current has to be 0, so there's no resistance. There's nothing here. Yeah, exactly. I like that. KVL, that's a great way to think about it. Okay. How much do I know about MOSFET? Not very much. No, that's like that's very specialized EE stuff. Okay. So this is 120 plus 12R1 all over 120 R1 is equal to 10. We agree with that so far? It probably would be, yeah. I've come too far though. 1200 R1 is equal to 120 plus 12 R1. I want to like divide by 12. Can I divide by 12 here? I got so many 12s, right? Yeah. Can I divide by 12? I feel like I can. Okay, so I get 100 R1 plus 10 equals 10 plus R1. So 99 R1 equals 10. So R1 is equal to 10 over 99. Did I fuck up on math? I've been streaming for a while. So yeah, whatever, like 0.1 ohms. Seems like not a lot of resistance. How much you have about 3-phase? I feel like I did this right. Oh, wait, whoa, this is all to the -1. Sorry, whoa. Sorry. I fucked up. That happens sometimes. Thank you, verified. Yes, that was bad. Okay. Flip-C. 1 over 10 is equal to 120 R1 over
120 plus 12 R1. Thanks, Zach. Yes, that definitely complicates things. Okay, now we're still okay. Wait, it's still 120 plus 12 R1 equals 1200 R1. Right, I don't really think that changed much. I guess it did a little bit. 12 plus R1 is
equal to 100 R1. Oh, okay. $12 equals 99 R1. What up to my voice? So there's a thing on my my Twitch where they can redeem things that turn my voice into a squeaky voice. It's kind of fun. Yeah. Good to see you, Jason. I do need to drink water. Thank you too. Yep. Nice. Thank you. I appreciate that, Zach. That was one of the most succinct explanations of the path of least resistance. That makes so much more sense. Yeah. Okay, so I think R1's equal to 12 over 99. Still doesn't seem right. What's the actual answer to that? That seems like such a small resistance. In order for it to be 10 ohms? So wait, that's basically like... I really like the grocery line analogy. Yeah. I'd still do the other 3 first. Okay. Let's see if we get the same answer. I may have like just messed up on the algebra. Also, I will just make sure this is all okay. Wait, R total. No, the math does feel off. I agree, Bryson. I agree it does. We're gonna do what Anthony said. He said just combine these first. I agree. Let's just do it. The line analogy, yeah, lunch. I hated waiting in line for lunch. Okay, 5 over 120 plus 1 over 120 plus 5 over 120. So that's 12 over 120. Right? Which is the same thing as 1 over 10, right? And then we say this is and this is all to the negative 1. Yeah? Wait. 5 over 120 plus 1 over 120. No, it's 11 over 120. Ooh, dear. What's up, famished? Yeah, wait. 5 plus 5 plus 1 is 11. Okay, cool. There we go. Okay, so an RT is 10, so I get 11 or 120 is good. Thank you, Zach. Okay. And RT is 10, so if I flipsy both, I get 1 over 10 is equal to 1 over R1 plus 11 over 120, right? So 1 over 10 minus 11 over 120 is equal to 1 over R1. Let's pull the calculator. Uh, 1 over... 1 over 10 don't you have to make it negative? I did when I subtracted it, right? Did I do that right, Bryson? I think I did when I subtracted it. No. One sec. I'll get it off the screen in a second. So you get 120. Okay. Well, that's cool. Yeah, so, Ash, what I did was, I know RT here is equal to 10. And then I inverted both. So if I invert the invert, that goes away, and that becomes 1 over 10. And then I get 1 over 10 is equal to this. That's how, Ash, that's how I got rid of... I avoided inverting the right by just inverting the left. Cool. Right, so R1 equals 120 ohms. I mean, that seems reasonable. You're good, Bryson. Okay, so 120 ohms. Is this right? Who submitted this question? I feel like it would make sense because, like, all these things are, like, 120s or 24s. I can do triple integrals, yeah. I think it makes sense. Is it because it's, like, symmetric or something? It preserves symmetry if you do that. Yeah. I agree with this, Zach, right? Yeah, if this is 120, I have 120 opposite of 24, 120 opposite of 24, 24 on the top left, 24 on the bottom right. Yeah. Yeah, come here for your calculus homework. All right, cool. I think this one's done. I'm done with it. Oh, man. Thank you for sticking with me, guys. It was kind of a fun one.
Well done.
I think this was Pullen's question. Yeah, this was you, Pullen. That is college level homework for sure. It was kind of a pain in the ass, honestly. Thank you, Zach. Appreciate the help on that. Can you run a Kahoot? Maybe on the weekends. We do things over the weekends like that. River. We do like fun little games. Join the Discord. Are you in our Discord yet, River? Go join our Discord. That's how you figure out when we do stuff. Although I'm at TwitchCon. I'm at TwitchCon this weekend, so I won't be able to do stuff. But next weekend. You're a junior EGR student, and my circuits class is a joke and has easier shit to do than homework. Yeah. How do you join? Go to the website, actualofficehours.com down there, and then there's a link to the Discord. It's right here. Right here. Link, join our Discord. Let me look at the queue. Let me get rid of pull-ins. So we did pull-ins. So let's do cluefuls. Like this. Cool. This is math. We like math. Where's Jeff? Jeff would be so happy we're doing math again. Yeah, upload your homework. Well, I mean, upload a question. I'm not going to do your whole homework. Upload something that's difficult on your homework and let me teach you. That's the whole point of this. That is vibe coded. Yeah, I vibe coded the whole queue. I did. Yeah, I definitely do algebra. Yeah. Screenshots. Screenshots. That's the best way to do it. Where can you post in chat? Well, it's the website. The website. Actualofficehours.com. Just click that website. You can't click it because it's a stream, but if you go to that, yeah. Okay. Easy way to get critical numbers. Set the derivative equal to 0. Let's do this. Consider the function f of x equals 2 cosine x for that. Find the values of x for which the tangent lines to the graph are parallel to this line. Yo, what? Okay. Alright, here's a key thing. Lines are parallel if they have the same slope. Same slope. And then the key thing with slope is that the derivative is equal to the instantaneous slope. Yeah, it's not a fucking line. I mean, unless, I mean, it's more of a curve, right? That's definitely covering that, yeah? That's not a line, yeah? Unless, do we think they fucked up? Do you think this is supposed to be square root of 2? Also, it can't be, right? Because, well, never mind, it could be. The radicand is square root of 2x. Okay, but that's not a line then, yeah, right, Zach? I don't think so. Okay. Okay, so I need... There can't be an irrational slope, but they said it's a line. Okay. This is a poorly written question. God damn it. I hate this when this happens. Because I was going to do the derivative of one is equal to the derivative of the other, right? But I feel like that would be really difficult. Okay, alright. I'm going to assume the slope here is square root of 2. Let's just assume that. Let's assume that's a square root of 2. Negative square root of... fuck. Whatever. Yeah. This is why I have trouble with it? Yeah. It's not your fault, dude. Believe me, everybody else in the chat is like...
Surprise, motherfucker!
Like, that sucks. Okay. Alright. So... the slope of this is negative square root of 2. Okay. So I need... for which the tangent lines to the graph of f are parallel. Okay. So that's where the derivative of this is equal to the negative square root of 2. Right? So f prime of x is going to be equal to negative 2 sine of x. Right? And I need that to be equal to negative square root of 2. Cancel, cancel. So, sine of x needs equal to square root of 2 over 2. This is beautiful. This is very easy to solve, right? Where is the sine of x equal to square root of 2 over 2? Especially on 0 to 2 pi, right? Unit circle. I know, you guys hate learning the unit circle. It's buns, but it comes up so much in math, dude. You really need to know it. Okay, square root of 2 over 2. Because I'm gonna do this for the kids who haven't like really taken any of this yet. This is like kind of like a little intro. One sec, this needs to be here. Also, TikTok thinks I'm scamming, so I have to pass a CAPTCHA test. There we go. Okay. If you have a triangle, to do anything with 30, 60, 90s, 45s, 135s, I don't care. You only have to know two triangles. So it's the 45, 45, 90, right? And this has side lengths 1, square root of 2 over 2, square root of 2 over 2. And then the other one you need to learn, we're not using it in this one, but I'm just going to show it for now. Is the 30, 60, 90. And that's 1 square root of 3 over 2, 1/2. Okay? If you know these two triangles, you can figure out everything in the unit circle, like on the fly, and it's so nice. So sine is equal to opposite over hypotenuse. So I need to know where the opposite of hypotenuse is the square root of 2 over 2. Okay? Well, that's going to occur here at 45 degrees, because according to my triangle here, right, the opposite will be square root of 2 over 2. It's also going to occur here at 135 degrees. All students take calculus. No, it's ATCS. All students take calculus. Because yeah, this technically has what's called like is this called like a reference angle? I think it's called a reference angle, right? It's called reference angle. And this is also square root of 2 over 2. It's not going to be down here. No. Because down here, the opposite is always negative. Yeah, all students take calculus. This is like all are positive, sine is positive, tangent is positive, cosine is positive. The other way I like to see it is that like, okay, the opposite deals with the y coordinate. Those are positive here. And the things that have opposite in it is like sine and like tangent. So sine is always positive up here. Adjacent is the x coordinate, and that's only positive here. So that's why cosine is positive here and positive here. And then tangent is kind of the weird one, because when both the opposite and the adjacent are negative, then opposite over adjacent is positive. Anthony has a trick. He says from top clockwise, you can think of each order square root of 4 over 2, square root of 3 over 2. Oh, I've seen that before. Yeah, that's another fun trick. Yeah, I know what you're talking about. I've seen it before. It's with like the table. Is this it? I know what you're talking about. Anyways, okay. So yeah. Dude, why does my brain get distracted when you actually teach something I could understand? I don't know. Put down the Fortnite or whatever you're like doing. Okay, so this is at 45 degrees and 135 degrees. So 45 degrees is pi over 4. And then 135 degrees is 3 pi over 4. And there you go. Those are your answers. How do I suggest you prepare for your linear algebra exam? S. Do practice problems.
Well done.
Best way to do well is to do. Nice. That was a good question, Clue. Let me add it. And then we're going to go to the next one. Rock and rolling today. We had a little bit of some internet issues earlier, but it seems to be stable now. Okay, this is Clue. All right. Clue's done. Next one is Droidify. Ooh, I like this. This is physics. Dr. Gold at night. That's what the stream is becoming. Yeah. I had kind of a late start today, and then the internet got fucked, and we hit like 160 viewers on YouTube, and I was like, I just have to keep going. I was supposed to meet up with someone for dinner. That sucks. Sorry, girl. Y'all are my date. Let's see. Yeah, it was pretty big. I mean, the record I've had higher, I think, when I was doing like the AP Physics review sessions, but it's definitely the highest here. Night clickbait. Yeah. All right, let's see. A rigid rod is rotated 1.7 meters on an axis perpendicular to its length through its center. The two are 7 kilograms and 9 kilograms. Oh, okay, cool. So this is 7 kilograms. This is 9 kilograms. Notice how they say a light rigid rod. That means it's basically massless. Love that. What is the angular momentum if the speed of each particle is 6? Oh, so that's the velocity. Okay. And the rod is 1.7 meters? Okay. So, I assume it's in the center. Not calling it ideal is criminal. Imagine a spherical rod. A spherical cow. So, that means if this is the whole 1.7, this is going to be 0.85, right? And that's going to be equal to R. Yeah? We agree with that? I know for angular momentum, that's L, is equal to I omega, where I, for just a bunch of point charges, like a bunch of point masses, that's equal to the sum of mr squared. So this sigma means I'm going to add up all the mr squareds. So I have m1 r squared plus m2 r squared, and then we got to all multiply that by omega. Omega is interesting. So you learn in kinematics that v is equal to r omega. So the linear velocity, the tangential velocity, see how this is like a tangential velocity? That's like how fast it's going in a straight line. It's really turning, but like at that instant, if it kept going, it would go straight. This is relatively simple. So v is equal to r omega, so omega is equal to v over r. And they told me what v was. They said v was 6. And then r is equal to 0.85. Cool. Slam that. And actually, I'm gonna leave the r up. I'm gonna say it's just v over r, because watch what happens. All right, cool. This is equal to L. Good. It only works with radians. Correct. Yeah, omega needs to be in radians per second for sure. Yeah, don't do degrees per second. Don't do it. Okay, cool. R's cancel. And so I get 6 times R. I can pull the R out as well. So 6 times 0.85. Or yeah, because I know someone's going to look at this later. Sorry. This is R. Sorry, this is VR. M1 plus M2 is equal to L. I don't want to skip like too many steps, because then people are like, what the fuck happened? And then that's 6 times 0.85. And then M1 plus M2 is 9 plus 7, 16. Beautiful. Can I just get this on its own? Maybe. I don't even want to use a calculator. Oh, but they have none of the above. Those fuckers, dude. When they put none of the above, I die a little bit on the inside. I'm like, wait, what? I can't just estimate this? Okay, 6 times 0.85 times 16. 81.6. Answer choice B. Good job. Good. How do the R's cancel? Okay, I'll show that. So, when we were here, Prad, mr squared, that was the I term. That's the moment of inertia. And then omega is equal to v over r. So I have an r squared here and an r squared here. And I have divided by r on the outside. So that's going to come through and kill off one of the exponents. So it drops the 2 down to a 1. If you wanted to look at this maybe a little nicer in terms of algebra, bring this down. You would have r squared v over r, and then it would be m1 plus m2 is equal to L. And then you can see that this cancels with this. Sopranos. I do like the Sopranos. Dude, yeah, fuck mastering physics. No. I absolutely hate mastering physics. It's the worst platform ever. I'll go on the record for saying that. It's the worst. Because I've seen it from your point of view. I understand as a teacher, because I've been on both sides. I've taught physics at UCLA. I've also, like, helped kids do classes that use Pearson to do physics. And Pearson does make it easy to teach, for sure. It's a very rock-solid platform. It's very lazy to just, like, click, like, assign homework, blah, blah, blah. You get all the stuff. You don't have to really do anything. But from the kid's point of view, Pearson is just absolutely trash. It's incredibly nitpicky. There's so much, like, monotonous work, and I don't think you really learn anything. You just learn that you hate physics. Because the questions are long and tedious for no good reason. Yeah. Were you a professor? Yeah. No, I taught over the summer, and then I taught in the spring quarter. I taught physics 5A at UCLA. I taught physics 1B over the summer. I'm not teaching this quarter because like they have money issues. So, go call your congressman or something. Anyways, good, great question. Who's that? Was that Droidify we just did? My math lab. That sounds bad too. All right, so this is Droidify. All right, cool. So Droidify. And let's pull Droidify's in. That's the worst, is when it's not even like a high percentage, and you're like, wait, why did I even do all this? And you kind of have, because the only way to get good at physics, and really any class in general, is to do practice problems. And so it sucks if like the practice problems are just garbage and just make you hate yourself. Because you're like, ooh, 1 attempt left. You've used all 7. Like, what? You wonder why, like, kids have, like, anxiety problems. And, like, it's probably mastering physics. All right. Let's see. Next, question, because Droidify just left. Jack Piggott. What's up, Jack? Jack, you still in my chat? It's the best when the test has a problem with something that you've never seen before. Yeah, whenever I wrote my tests, every single question on the test was something that had been seen at least in lecture, homework, or like TAs, or like office hours. I never put something on a test that no one had ever seen any, like, sense of it in some point. Pearson ruined me in thermo. Yeah, I agree. Okay. Oh, wait, you're still here. Clickbait. Oh, I thought you left. Is Moodle a thing? Yeah. The study guide isn't harder than the test? Yeah. Okay. How long did I study physics for? I mean, I did my PhD, so I studied physics for way too long. I studied physics till I was 31, probably. I mean, I feel like I still study physics because I still help people, but... And Laplace transforms do suck, yeah. But Zach can probably help you out with them. Yeah, another key thing for all you guys that are watching right now, because I will probably have to end the stream in like 30 or 40 minutes. But we have other streamers that also do awesome streams like this with math and science. And so if you ever want to see who's doing that, Zach, who's in my Twitch chat, is another really awesome math streamer. And you can figure out when he streams by, again, the website you use to submit your screenshots. There's also a button for the streaming schedule. And there you can see, like, when people are streaming. So Zach had a stream earlier today. If you want help on Saturday, Zach will be around 9 a.m. on Saturday. You early birds want to get the worm, Zach will be there to help you guys on Saturday. So please go check out the calendar there. Follow people on Twitch. And then we're also streaming again tomorrow on Thursday. I'm way past my, like, streaming time right now, but fuck it. Where do you send questions? Actualofficehours.com, that website. Send it to the website. Submit your question below to the website, and it will show up here. My test today had me find static coefficients with no mass and circular motion. I did not learn how to do... Oh, no. That is a... Yeah, you don't need the mass, Sebastian, because it cancels. The M's cancel. I definitely do chemistry, yes. Let me do this question, and then I'll answer more things in chat. Thin rod of length L and total charge Q has a non-uniform... God damn it. Where X is measured from the rod's left end. What is lambda naught in terms of Q and L? What is the electric potential on a distance D to the left of the rod's left end? Okay. Where X is measured from the rod's X. Wait, sorry, what? X is measured... Oh, okay. I need to draw a picture. I need pictures. I'm a very visual person. Okay. This is Sir Rod, right? And then this... is a distance. Right? This is like the x-axis, yeah? And then we know it goes out to L, right? And then x is measured from the rod's left end. Okay, cool. And then sigma is equal to sigma naught x over L. And then it has a total charge Q. Great. I can do this really easily. Okay, so total charge, so Q total is equal to the integral of dq. Okay? dq is equal to lambda dx. Okay? So the change in charge, like a little, we like to say like a little part of charge here, like a little sliver right here, right? Little sliver here is technically equal to the charge density there times like how wide it is, and that's dx. All right? And then you just integrate those all over each other all the time. Yeah. Yes, and Joe, Zach does complex variables. Yeah. Zach has a PhD in math. My PhD's in physics. So if you guys want to ask really, really hard math questions, go ask Zach. He's great. I learn from Zach all the time. I think eventually, Zach, I will have what I would consider like the ability to start math graduate school if I keep like watching y'all streams enough. Did I ever consider a PhD in math? No. Dude, one PhD is enough. Trust. Okay. So, dq is equal to lambda dx. So, this is equal to... Also, like, I'm a very hands-on person. Math is not as... I would say it is hands-on, but it's not like... You're not like touching a screwdriver, you know? Like, I want to touch, like, electronics and stuff. Just get a master's in applied math, yeah. Math PhD is all proofs. Physics stuff is computation mainly. Yeah, if it's theory. In my case, it was a lot of experimental. So I was like sticking probes in like plasma, and I was like measuring voltages and ramping up batteries and currents and like burning shit. It was fun. Okay, the bounds. So x is going to go from 0 to L. So if we go from 0 to L, that is going to add up all the little individual dq's along my rod from 0 to L. Okay, and then lambda we know is equal to lambda naught x over L. Sweet, I love this. So this is the integral from 0 to L, lambda naught x over L dx. Right, so that came from this, x naught. Oh, I went to UCLA. Lambda naught x over L. So then, this is constants. And we're left with the integral of x dx. Integral of x dx is x squared over 2. So I have lambda naught L, x squared over 2, evaluated from 0 to L. And then this needs to be equal to Q, right? Big Q. Q total, yeah? So, that's just going to be lambda naught over 2, L to the third is equal to Q. So then lambda naught is equal to 2Q over L cubed. Nice. What, the sigma? This isn't calc... I mean, it is calculus, but it's technically physics. Cool. All right. Sweet. Okay, so that's the first part. Late stream. Yeah, late stream today. The people called for it. I kind of had to. Okay, so what did we figure out? We figured out that lambda naught was this. That's cool. I mean, we can use that later probably, right? Let's use it later. What is the electric potential on the axis to the D to the left of the rod's end? Okay, so that's saying, like, what's the electric potential located at a distance here, D? So, I'm going to do this. I know that potential is equal to KQ over R. But, it's really, for point charges, is equal to the sum of KQ over R. And what I'm going to do is I'm going to pretend that this rod is just a bunch of tiny point charges. and I'm going to add up all the little tiny point charges. The way to do this, such that like adding up all the tiny point charges is like adding up a continuous distribution of point charges, is to convert this to an integral. So I'm going to convert this into the integral of k r dq. Okay? Now, dq, we already knew was equal to dq is equal to lambda dx. Oh, and this is interesting, actually. Yeah, you got to be careful here. So, yes, this is k lambda dx. We need to be careful about what r is, and we need to figure out how r relates to x. This is the key thing that messes people up. Okay, this r is weird. R refers to the distance away from D. D is where I'm measuring the potential, to where I am adding up my little pieces, my little point charges. And so that R, so in this case, let's say that this right here is X, then R is equal to D plus X. Exactly, Zach. It is Coulomb's law. I did the second step wrong? Oh, Alistair, what did I do? What did I do wrong? Someone said I did something wrong. Also, I like throwing these in ChatGPT just so I can check myself along the way. I haven't actually. Let me throw this in real quick. Someone said I had the second step wrong. Isn't it lambda over x? Oh, it is. It is. Thank you. Yes. Wait. No, it's not lambda over x. It's lambda not x. Wait. This is okay. What are you saying, lambda over x? Wait. Oh, I mean lambda over L. Yes. You are right. You're right. You're right. Thank you. Yeah, sorry. That was a transcription error. Thank you. Yep, no, you're good. Okay, so then it's just L. Cool. Good. Nice. That fixes that. Thank you. Cool. We don't really need that yet, but yeah. Okay, good. I make mistakes too. And was it supposed to be 2Q over L? Yeah. ChatGPT also agrees. Yeah. That's what ChatGPT says, so I agree. It's a good little sanity check. Okay. Well, let's go back to here. Okay, so R is equal to D plus X. So we're going to leave this as D plus X. All right, and then we're integrating this, again, still from 0 to L. Because that's where all my little point charges lie that create this rod. Okay. So this is equal to K lambda integral from 0 to L dx over D plus X. This is a U sub question. So I'm going to say that U is equal to D plus X. So du is equal to dx. So then this is K lambda, don't worry about the bounds yet. And that's du over U. This is ln of U, right? So K lambda ln of U. And then now I'm going to replace U with this. K lambda ln of D plus X. And then this is evaluated from 0 to L. So I get what? K lambda ln of D plus L minus K lambda ln of D, which is equal to, if you have the ln of something minus ln of something, that's the ln of that divided by that. So this is K lambda ln of D plus L over D. I think this could be AP Physics C, maybe? Yeah. Oh, I fucked up. There's an X somewhere. Wait. Yes. Okay. Nope, nope, nope. I can tell in my 4th hour streaming, I'm making mistakes. Yes. So here's a mistake I made. Lambda depends on X. Don't forget, lambda is equal to lambda not X over L. Wow. Don't forget. No, no. ChatGPT agreed with this. This was correct. Part B was not. I hadn't checked ChatGPT yet. Well, I just checked ChatGPT, and the answer looked a lot more different. I was like, oh, I screwed up somewhere. I screwed up because I did not substitute lambda with its non-uniform function. Oh, you're trolling. Yeah. Hardest test I ever took? Probably the physics GRE. Thing sucks. Okay, so K lambda naught over L. You just use 0 substitution, right? Yeah, exactly. Okay. So this is 0 to L. And then this is X over D plus X dx. Physics GRE, I think so. Oh, that's actually a good question. Yeah. Okay. Zach, how do we do this integral? Am I dumb? You can divide those. Do I want to, though? How can I divide those? Like with long division? Do I really want to do that? Oh, okay. Polynomial long division. Fine. Let's do it. Okay. Okay, so x divided by d plus x. So this goes in one time, right? And then that's x plus d. So subtract. So you get minus d. So it's 1 minus d over x plus d. Is that right? Holy shit. Oh, that's cool. I don't think I've ever seen that. And I've taught a lot of physics. Okay, so this needed polynomial long division. Poly. That's an interesting technique. I haven't seen that in a while. That integral is much more reasonable. I agree. Okay, lambda not L. So 0 to L. 1 minus d over x plus d. Okay. So, and then this is all still dx. So that's going to be k lambda naught over L. We're going to get, this is just going to be x. So this is just going to be L. L minus 0, right? And then minus this integral. This integral. That's d. And then I think it's ln of x plus d over d. Right? If I remember how it worked last time, right? Oh, but that was evaluated from 0 to L. Yeah, it's good. Oh, sorry. No, I'd already done the integral. I've just done the integral like ahead of time. I've just like done it in my head. Because I remember doing this integral. I did this integral already, I remember. And I think it was this. What? Oh, it's just D. Oh. No. Sorry, you're so right. It's this. Sorry, I was getting ahead of myself with the bounds. No. No. Okay. Sorry, I'm skipping too many steps. I'm not gonna do it. Not gonna do it. Okay. 0 to L. D over x plus d. Dx. U equals x plus d. You can pull this out, right? And then du is equal to dx. So that's d integral 0 to L 1 over u du, which is going to be d ln of u. So I'm going to say ln of x plus d evaluated from 0 to L, which is going to be d ln of L plus d minus ln of d. So that's d ln of L plus d over d. Okay, and then all of that goes up there. Okay, I think we're almost there. We're almost there, guys. Oh, sorry, there's another d ln of d. Yes, thank you. Thank you. Okay, so k lambda naught over L times L minus d ln of L plus d all over d. Good? I think we're good. And then lambda naught was something special. What do we have at lambda naught? Lambda naught was equal to this bitch. Okay. So now that's 2kq over L squared. L minus d ln of L plus d all over d. I think that's right? 2q over L squared. Okay, this is what they had for the final answer. Do we match chat? Moment of truth. 2, this is k, cool, q over L squared, L minus d ln of L plus d. Yes, cool, nice, love it. That's it. Good job, guys. Oh my god. This question was very involved.
Well done.
The physics on this question was easy, but then like the calculus ended up being kind of a slow roast, right? Nice. All right, whose question was that? That was Jack Piggott. Interesting name, Jack. Love it though. If anyone's looking, if you want to see where these, like, the solutions, I'm uploading all the solutions to Discord. So join our Discord. It's the link down below. It's there. Have I ever failed a class? Yeah, I failed quantum. Totally. I failed quantum mechanics in my first year of graduate school. Yeah. And by fail, in graduate school, if you get a B minus, it's failing. So I didn't get like a D. Also, to be fair, that class was fucked because it was 90% final exam, 10% homework. That was the grading rubric. 10% did you do the homework during the class, and 90% was the final exam. So I kind of freaked out on the final. I was like, yo, what? I remember because it was like a 3-hour exam for the final exam. Like an hour in, I was just like losing it. I'm like, oh dude, I'm getting railed. And I just stood up and I walked outside the class and I just did a lap. I just walked and did a lap around the building. I was like, I need to take some time out here. I still got credit. No, I still got credit, but like, I guess failing is the wrong word. It's seen as not good standing to get a B minus, and so they cut my funding for like a quarter. It was annoying. I had to like find other ways to make money that quarter. Yeah, totally, dude. Yeah, in grad school. Well, this is also before the days of ChatGPT. Before the day, like, they knew you weren't gonna cheat. They're like, you're fucked regardless. What the fuck are you gonna do? What are you gonna look up, dog? Like, you're screwed. In grad school, B minus is bad. Yeah. I think B minuses are fine in any other class, but in grad school they're bad. Yeah. So, fair warning to grad school people. All right. Next one is John Terry. What grad school? UCLA. Plasma physics is what I was doing. John Terry. Ooh, I like this. This is another fun question, John. Why do I get the feeling that John Terry and Jack Piggott are the same person? Because they're all asking me E&M questions. How do they know if you're having a horrible time mentally? They really don't care. They probably care more now. But yeah, back in the day, I didn't really care. I mean, you also have to understand, a lot of these professors came from like the Soviet Union, which was a very like fuck your feelings type country. I mean, like if you were upset, you got sent to the gulag. They didn't give a fuck. Like, you either do work, comrade, or you go break rocks. So I understand in physics, at least, there is kind of like a kind of more hardcore mentality, because a lot of the professors came from places where like life was pretty difficult. So if someone says they're sad, they don't take that seriously. They're like, sad? That's your biggest problem? You're sad? But mental health is important. You know, I empathize with you guys. But I'm just saying, that's why like some of your older professors don't just seem like they don't care, because life was a lot harder for them. Okay. As shown in the figure, Q1 is 2 microcoulombs located at the origin, 6 microcoulombs located that. Find the total electric potential due to these charges at point P. Okay, cool. KQ over R. Yeah, baby. KQ over R. Rock and roll. Although I gotta remember. I think this is just KQ over R, because potential is a scalar. I don't really care about the direction, right? I don't think I do. Habaka says KQ over R. Oh, I'm sorry, Bluego. Come get help here next time so you don't fail. Yeah. Fuck, midterms are Friday. Well, we still have a stream on Thursday. So you can come get help tomorrow. Okay. Yeah, let's just do it. A. Potential is equal to the sum KQ over R. So that's going to be equal to K times -6 times 10 to the minus 6 over this R. Beautiful. This is a math thing. No, I do math questions too, man, dude. I do so much shit, dude. What? Yeah, well, a lot of it's been physics today. But I did some biology earlier. This was math. We did a proof by induction. I did proof by induction today. I'm so proud of myself. I did a proof by induction. This was more math. This is like vertex form of like a polynomial. Yeah, just because we're doing like super hard physics right now, and this isn't really super hard physics, doesn't mean we do all sorts of other things. It's just I have a lot of people asking physics right now today for some reason. I do chem problems, I do stats. Flan says, how hard is it to get into plasma physics? I'm currently getting an undergrad degree in honors math and physics, and I'm ramping up myself to study to prepare for grad school. If I can do it, you can do it. Most important thing for getting into grad school is research experience. So I luckily, like, if you know what REUs are, REU, research experience for undergraduates. So also, I'm assuming you're in the United States. Try to do a couple of those. And it helps if you do them in plasma physics. But the nice thing about the PhD programs in the US is they don't really require you to know exactly what you want to do yet. You just have to show that you have like a proclivity for doing research and like you're interested in it first. Yeah. Duolingo's evil cuz. It should give you the link, I hope, for where to do it. The link is also down below. That's actualofficehours.com. Also, actualdiscord.com/submit works, technically. I need to change that. All right. But first off, ladies and gentlemen, this is a very important thing. Who says I'm only doing physics, bro? This is a math thing. Okay. If this is 4 meters long and this is 3, it also works. Both websites work. And you tell me, Sebas, I think actualofficehours.com is easier to like think about, because when people see like actual Discord, they're like, wait a minute, does this go to a Discord website? It does eventually, but it's more than that. So I bought another domain called actualofficehours.com because that website's mainly used for office hours. But you tell me if it's... Okay, hieroglyphics. Love it, dude. So anyways, this is 4 centimeters. This is, 4 meters, 3 meters. This is called 5 meters. Look, it's a 3, 4, 5. I don't know. I just love it when this stuff shows up. I'm just like, yes. Okay. 3, 4, 5 means that like 3 squared plus 4 squared equals 5 squared. It's the Pythagorean theorem. Don't even have to think about it. Just easy money. Okay. So KQ of R, so that's KQ over 5. And then plus, that's going to be 2 times 10 to the minus 6 all over 4. Okay. So that's going to give us our potential. What is that? I need a calculator. I was thinking about doing it in my head, and then I thought not. 9 e to the 9 times negative 6 e to the minus 6 all over 5 plus 2 e to the minus 6 all over 4. Negative 6,300. Wow, that's big potential. I guess it makes sense. Microcoulombs, yeah. Put the calculator away. Okay, so negative 6,300 volts. Nice, Duolingo. Cool, I'll check it. Boom, boom, boom. Does E mean e to the minus 6? No. Sorry, where do you see the E? Oh, you mean on the calculator? The E means times 10 to the. Yeah. So if you ever see like 5E3, this is the same thing as 5 times 10 to the 3. It's just a shorthand way to do scientific notation. And you use a law on a calculator. Not Zach. That's the Zach constant. The 2.71? 2.71, right? 17? 2.71. Okay, cool. I think that's correct. Okay, let's look at point. Okay, find the change in the potential energy of the system. Ooh. So, before I even start this, so potential energy of a system is equal to, I think it's equal to QV, right? Is that what it's equal to? Yeah. So that's like a charge being in a potential somewhere. Okay, find the change in the potential energy of the system of the two charges plus a third charge Q3 as the latter charge moves from infinity to point P. Okay, so if PE equals QV, then delta PE is equal to, we're going to say Q3, and that's like V final minus V initial, right? Now, Q3 is 3 microcoulombs. And then, let's see. As the charge moves from infinity to point P. So, at point P, I know the potential is equal to this. Right? Because we're... And also, you're figuring out the potential due to the other two charges. Not the third charge. The energy in the system... The change in the energy here is the energy change from taking a charge Q3 located way out here at infinity, where the potential is 0, right? Do you see how, because potential goes as 1 over R, so as you get really, really, really far away, the potential is 0, and so there's no potential energy. But then as you bring this thing closer in, now there is potential here, and that potential will make a non-zero potential energy. Yeah, middle school up through like college. Yeah. Okay, so V final, that was negative 6,300 volts. And then this is like out at infinity, where KQ over infinity is equal to 0. So this you can just write 0. Right? So, yeah. So the change in potential energy is equal to, what is this? This is 6.3 times 10 to the 3. 18.9 times 10 to the minus 3. So if you move that over, what is it? I use LURD, left up. Okay, so this goes up. So 1.9 times 10 to the minus 2. Right? 1.89, sorry. And then that should be joules. And then negative. Yeah, there's a negative change in energy. Oh, let's see. What did ChatGPT get? Yeah, 18.9. Thank you. ChatGPT said 1.89. I'll take it. Nice. Cool.
Well done! Well done!
I think it's minus. Oh, wait. Q3 was... No, Q3 is positive. So I think it should be negative. Can I solve... Oh, differential amplifiers? Not really. Yeah, so this is negative. No. VI is 0. So, as the charge moves from infinity to point P... You're good, Zach. This is VI. And then this is VF. At infinity, there's 0 potential. When you're way out at infinity, you don't see anything. Like, nothing affects you. And then VF is at point P. And then change, delta, is always final minus initial. So that's why it's negative. Yeah, this is college level. I'd say it's college level. Okay, so that was John Terry. Load it up. Yeah, no, totally. Yeah. You're good, Zach. Yeah. Usually things go out to infinity, but in E&M we talk a lot about bringing things from infinity to a position because that's where 0 potential is measured. But potential is only relative. There's no absolute potential. What is this? John Terry? John Terry. Cool. What's the difference between using VF minus VI and V minus V0? Nothing. Just convention. I prefer to actually... I would do V1 minus V0 is what I would use, Sebastian. And then, Jack and John and chat are the same. Okay, cool. Yeah. I would do like V1 minus V0 because sometimes in physics, instead of having just like a beginning and an end, you also have like a middle situation. And so then I'll be like, okay, cool, V0, V1, and then like V2. I like the number to denote like what's going on. Jack, John in the chat are the same. Okay, cool. All right. Ooh, this is maybe some Zach stuff. What does the underscore mean? Does it mean multiplies? Where's that from? Can you solve JEE questions? Dude, the JEE ones are just pain, dude. Sorry, this is negative and then this is minus, is what this is. Okay. Oh, subscript. Oh, the subscript just denotes which one it is. So, in the case where you have multiple situations, like, say when something's here versus when something's here, the subscript here tells you which potential you're talking about. In this case, V sub F means I'm thinking about the final V. This means I'm thinking about the initial V. I get it. I get the subscript. Yeah, no, I get what you're saying now. Yeah, in LaTeX, that is also a subscript. Okay. 3x minus 7i is greater than 3 times x minus 7. I assume this is also an I. Can you explain quantum entanglement? Maybe if I wasn't 4 hours into a stream, I would. Come by tomorrow. I'll try and explain it. But quantum entanglement comes down to like things can only either be like yes or no. And so if something is yes somewhere else, it has to be no somewhere else. Like things are entangled. I think the way to maybe think about this is let's say you have I'm trying to think of something that breaks into two pieces. I'm losing it. Okay. Let's say you have a baseball and a bat, right? In a box. And you're like, cool, I need to bring this box to go play baseball. But before I do that, I'm going to take one thing out of the box and put it in another box, okay? And then I'm going to take the two boxes and put them like really far away. If I open one box and I see there's a bat, I already know the other box has to have a ball. So entanglement is like the knowledge of where something is will instantly tell you where the other thing is. And where this gets weird is sometimes that violates like the speed of light type stuff because information is traveling faster than light. I think that's what it is. Yes, I think that's what it is. Okay. What is this? All right, wait. 3x minus 7i is greater than 3x minus 21i? Is that what we're saying? So what? 0 is greater than negative 28i? I'm confused what this is a question about. Yeah, what are we solving for? Are we just saying, is this true? What? Okay. When this happens, dude, I'm sending this to chat. I'm gonna see if chat can get it. Solve this. It'll be really cute. I just want to see what it says. I have no clue what I'm solving for. I assumed I was solving for x, but then it just cancels. KY, yo, thanks for saving me again. For sure, dude. Maybe graphing? Graphing what? Try solving it with you? What do you mean solve it with you? Oh, that's a U on there? Dude, ChatGPT, you broke ChatGPT. ChatGPT doesn't know what to do with this. Okay. And then what is this? Okay. F of x equals x to the x for x is greater than 0. I agree, because I don't think you can have 0 to the 0. And then they say find d squared dx squared of f of x. So find the second derivative of this. Oh, okay. I know d dx of a to the x is equal to... Is it 1 over a ln of a to the x? Is this it? Okay. I remember I have to do it this way. Sorry. A to the x equals y. So ln of a to the x equals ln of y, right? And then, I think I take the derivative of both sides. Right, I do d dx of both sides. Oh, so then this is x ln of a. A to the x equals y. So ln of y is x ln of a. Okay, cool. And then what do you do here again? Oh, okay, wait. So then, oh, I think I know what I do. I do d dx of both sides. And then that becomes ln of a is equal to 1 over y dy dx. Okay. Okay, so then dy over dx is equal to y ln of a. And then y we already said was a to the x. Okay, so it's a to the x ln of a. Oh, Among Dreams says I got x to the x 2 ln of x times x to the x ln of x squared x to the x plus x to the x minus 1. Do implicit differentiation. I don't know how to do that for this. Wait, what? Let me see on the last question. Sorry. The one that, dude, this is still getting hung up on ChatGPT. ChatGPT still doesn't know this one. No need for implicit differentiation. Okay. Take the ln of both sides. Yeah, I think so, right? I mean, that's how I did it with this one, right? So if you say y is equal to x to the x, and then take the ln of both sides, right? So ln of y is equal to x ln of x. Very cool. Okay, now you take d dx. This is easy then, right? So I get 1 over y dy dx. Oh, submit a question, Adrian, if you want. The unit circle is how you find critical numbers if your function is sine and cosine in it. Okay, the derivative of this is derivative of the first, which is 1 times ln of x, plus the derivative of second, which is 1 over x times x, right? Oh, so that's just 1, yeah? So dy dx is equal to y ln of x plus 1, yeah? So dy over dx equals x to the x ln of x plus x to the x. Okay, cool. Oh, and then you want to take another derivative? Oh man. Okay, well I know the derivative of x to the x is. It's this, right? So if we do another d dx, this is kind of cool. D dx of this. Okay, well this part is just what this whole thing was anyways. Okay, cool. So whatever. This is x to the x ln of x plus x to the x, yeah? And then derivative of this is a product rule. You look evil today. Get some sleep, sir. I do need some sleep. Okay. This is a product rule. So it's x to the x ln of x plus x to the x times the ln of x plus x to the x 1 over x. Cool. All right, putting it all together, what do we get? X to the x, ln squared x, plus x to the x, ln of x, plus 1 over x, x to the x, plus another x to the x, ln of x, so this is going to be 2 of these, right? And then plus another x to the x. So what is that? X to the x ln squared of x plus 2 ln of x plus 1 over x plus 1. I think that's I think that's right. Did I do something wrong? I think it's okay. A lot of ln's, dude. ChatGPT still doesn't know what to do with this one. You broke ChatGPT, dude. Nice. Okay. Duolingo's evil cousin. What's up, Ava? Ava Usagi? I identify as a Husqvarna Svartparlin 401. Is that like a dirt bike? Dude, ChatGPT gets broken by a lot of things, dude. Try Gemini. It's one thing I don't really pay for. Okay, here we go. Oh, cool. This is what they got. Is that kind of the same thing as what we got? It's some sort of bike I found off of Google, so I can identify something else. That's just too funny. Oh, I see this. Do you see how you can... Bro, do you see how you can add these together? This is the same thing as ln of x times ln of x. I feel like there's an ln of x missing here somewhere. It looks so close. This is close. I need x plus 1. Okay. ln of x plus 1 squared is ln of x. ln squared of x plus 2 ln of x plus 1. Oh, it is. Wait, why is that? Oh, that makes sense. Oh my god. So sorry. It's ln of x plus 1. I thought this was ln of x plus 1 squared. Okay, we got it right. Nice. Good job. We got him.
Well done! Well done!
Nice. That was a fun one. Okay, I'm gonna have this be the last question of the day, because we've hit many hours today. But we'll be back tomorrow. What's up, Harshit? This is Barrage. Okay. Is this just asking you to, like, draw, like, what's happening? So... No, you're good, dude. Okay, so f of t is negative, but it's increasing. Okay, so if it's negative, right? Fuck. Sorry. Okay. If it's negative, that means it has to be down here, right? And it has to be increasing. So it has to be doing this. So that means f prime of t is positive, right? And then it says the slope is decreasing. So here's kind of the weird thing. Decreasing means getting more negative. This is like more... So, Kumar, I'm ending the stream after this question, but the website there, actualofficehours.com, that has where you can submit questions. And more importantly, if you want to join our Discord, I will be on tomorrow. I've been streaming for 4 hours today, so I'm taking a break after this. So, decreasing is more negative. So, right here, the slope is positive. But I need the slope to be... Wait. F of t is increasing. Wait, how can f of t be increasing, but f prime of... Oh, the derivative is decreasing. Oh, that makes sense. Okay. So, the derivative is going from being very positive to not so positive to a little bit positive. Do you see how this is a derivative that's decreasing? You can say this is like plus 3, plus 2, and like plus 1. Right, okay. So if it's up and then less, okay, that tells me it has to be like kind of curved. So that's going to look like this, okay? Another way to talk about this, if f double prime is decreasing, that means f double prime is negative. And so this is concave down. Is that what they want you to say? Concave down? Yeah. Yeah. And then, again, f double prime of t is equal to negative. That's things that look like this. I say these are sad faces. And then f double prime of t is positive is what we call happy faces. Okay? And they can be either part of the curve. And yeah. Okay, and then the important thing here is that, like, f prime of t is decreasing. I see. Oh, this is kind of cool how this works. And then this is f prime of t is increasing. Does that make sense? Barrage? Does that make sense to you? Kind of like the happy face, sad face thing? Okay. So let's look here. So I'm actually gonna work backwards. Okay. F prime of t is increasing. So that means we're concave up. Right? So I know automatically I'm doing something like this. Right? And I know it's positive. So then it's just this. Right? So it's up here. That tells me it's that. And then because it's decreasing, that tells me it's the left half of the smiley face, because that's where the slope is getting, that's where the function is decreasing, right? Function is decreasing here, it's increasing here. So that tells you it's this. So maybe that's the way to think. I would maybe think backwards. Barrage. Look at this, concave up, cool. Decreasing, so f prime is negative. And that tells you instantly it's like that side of the happy face. Here, so this is, yeah, positive, negative, negative. Okay, so positive tells you you're up here. Nice. This tells you you're concave down. And then this tells you you're decreasing. So looking at this, where are you decreasing? You're not decreasing here. Right? You're decreasing here. So that means it must be this. Yeah, exactly. Good. I'm going to calc right now, early stages. This is probably like, I would say 2 or 3 months in. 2 or 3 months in for sure. Okay. So this is below. This is increasing. And then this is concave up. Okay, cool. So concave up. Increasing tells me it's just this part. And then this tells me it's below. So then it must be like that. Do you kind of see the train of thought I have there? Like, I draw the whole thing. Then I know, like, which half of it I need to draw based on this. And then below tells me whether I place it up here or I place it down here. You're still in derivatives of inverse? Full quarter in, yeah. So this is below. F double prime is... F prime of t is decreasing. So if the slope is decreasing... that's concave down, right? So down, decreasing is this part, and then you're below. So that's here. And then this is above. Increasing is this. Oh wait, they are fucking with you. They start changing the thing. They start changing the orders. God damn it. Oh, that's so mean.
What the fuck is this piece of shit?
Above, concave up. F prime of t is positive. So then it's this one. Okay, so then it looks like this. I agree with this. Concave down. Above. Increasing. Good. That looks fine. Ft is negative, so that's below. Concave up. Decreasing is this part. So then it's like this. Cool. Good questions. Barrage, does that make more sense to you, how we do this? This is kind of just like a practice thing you really got to do. But if any of those like little parts didn't make sense, you got it. Okay, awesome, good. You cooked, bro. You lived up to your name. Love it. I'll put this in the in our Discord. So if you haven't joined our Discord yet, there's links. You can just go to actualofficehours.com, and then there's a link for our Discord. Also links for all our socials. You can add stuff. Changing the orders, yeah, that's mean and annoying. Okay, cool. All right. It is 9 p.m. I'm way past my stream time. So let's close out the stream.
That's dope.
Thank you everyone for coming to Actual Education Office Hours today. Really appreciate all of the questions. I had a fun time with you guys. Thanks for being patient with us at the beginning. I know we had to restart the stream like an hour in because the internet was screwed, but thank you. If you want to figure out when we're streaming again, the website is actualofficehours.com. And there is a thing here for a streaming schedule. Click on that. You'll figure out when we're streaming. I will be streaming tomorrow at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. So come on by if you want to get help. That's the last day I'm going to give help. Zach's giving help on Saturday. I usually give help on Sunday. I'm going to have to remove this because I'll be at TwitchCon this weekend. But I'll tell you all guys about that on Thursday. Okay. All right. If you're watching us on Twitch, yeah, please. The best way you can support us is liking, following, sharing. You guys being active in the chat already does a lot. We hit like an all-time high today.
That's dope.
Of like concurrent viewers. I think we hit 160. I've never done that before. So thank you guys for like participating. All that stuff does great stuff. Like here, if you guys want to see, yeah, this is, look at that. Oh yeah, we had 197 people were viewing the stream at one point. That's really, really cool. We're punching through the brain rot and the feet pics with more educational fun stuff. All right, but if you're watching us on Twitch, I invite you to go follow us on Twitch. It's an easier format to see things on your desktop because it's horizontal. But we're gonna go raid somebody. Live astrology with Astro Canuck. You appeared while brain doom scrolling. Good. That I do. I appear a lot while doom scrolling. So I'm happy you found us. Make sure to turn on notifications, whatever. And like, if you ever have questions about your classes and you want to get help live on the stream, we are here to help you guys. Cool? No, back to my AI slop. I know. Okay. The party doesn't stop, though. If you're on Twitch and you want to go check out Astro Canuck, please do. He's an awesome astronomy streamer, and he's doing some cool stuff over there. Otherwise, have a great rest of your Wednesday. We'll see you tomorrow. Peace.
It does not make any sense. Actual education, let's go.